So I think so, yeah, that was part 6. My next part is going to be, again, VPC peering in a bit more on the transit gateway, which includes transit gateway peering and then transit gateway route table. So transit gateway is a huge topic. We're covering just the basics of it in here, but I hope it can make sense. So this is where we left off in the previous part. So I'm just adding some more public and private subnets into my VPCs. And then what I'm saying is that this is a spoke VPC, then this is a centralized VPC. And by that, I mean, these VPCs through the transit gateway can talk to this one and then out into the internet, right? And then what I'm doing is I'm adding some, I would say ENI, so Elastic Network Interface, right? So, and then in these private subnets, usually what happens is when you're using transit gateway, then you use a specific, I would say, a reserved subnet, and that's used for this ENI. So you get a subnet reserved for ENI, you put an ENI into that, and then that ENI is connected to the transit gateway. And from there, you wanted to reach out to the internet. So see how this works. So you have, I would say, your spoke VPC here, and another spoke VPC here. You have your EC2 instance. There is an ENI. So in this one, I haven't put a separate subnet, private subnet for the ENI, but just for the sake of space. But you get the point. So whenever you're putting ENI, it's a good idea to give it a separate subnet. So from EC2 instances into the subnet, into the transit gateway, and the same for this one, it goes through the ENI subnet of the centralized VPC. And from there, it goes into the NAT gateway. You remember in here, we talked about the NAT gateway. It is for outgoing traffic and then out into the internet gateway and then into the internet, right? So this is how it works. The purpose of a centralized VPC is like you have only one NAT gateway, right? Say this VPC wanted to reach out to the internet, it needs to get like a separate VPC, and then it has to have like its own NAT gateway, and then this one have another NAT gateway. It will be too much and too like it will be like I would say more complex architecture. The easy way is to have a transit gateway and then get a centralized VPC connected to this transit gateway. So now I have like 2 VPCs. They can be like multiple 20, 100 VPCs, right? All connected through a transit gateway, and then you have one centralized VPC that you go through the internet. So if you wanted to have multiple VPCs talking to the internet, you get a centralized VPC, you put an ENI subnet in here, you put a NAT gateway in the public subnet, and then out into the internet. And one thing I think so I forgot to mention, always and always your NAT gateway, NAT instance in your Bastion host, right in here, they have to be put in the public subnet. I think it's obvious because if you wanted them to be talking to the internet, they have to be publicly accessible. That's why they are in the public subnet. Okay, and now what happens is if your transit gateways are in 2 different regions, they can also be connected with each other through the transit gateway peering, right? So now this transit gateway in this region and this transit gateway in the separate region are connected to each other. And then we talk about like something called the transit gateway route tables, right? And then for that to understand, I'm going to put my face down here. For that to understand, I'm just adding some more VPCs with some more, I would say, CIDR ranges or IP ranges, right? And then I'm adding another VPC. Now you understand why, right? So, and then we have now, since these VPCs are connected to this transit gateway through different attachments. So if it's a VPC M, so it's attachment M, VPC N, attachment N, VPC P, attachment P, right? And then what happens is, if you see in here, right, you have the 20/16 VPC, which is VPC P. It goes through the attachment P. It's really small, but let me just do something quickly here. I wanted to make it a bit bigger so you can see what I mean. So here. So this is the route table for the transit gateway. So, and then these are its attachments. So we have different VPC. If it's a 20.00/16 VPC /16 attachment, it goes through the attachment P to this one, which is this specific VPC. If it's a 30/16, it goes through the attachment M to this VPC. 40/16, it goes through the this VPC. So this is how the route table for a transit gateway works. So what I'm going to do is go back and make my full screen. The event is so small. Anyways. Okay, so this was the concept of, I would say, a transit gateway. So you saw this thing appears, the VPC peering, right? So now let's just talk about, so I did talk about the transit gateway first, right? And then I talked the VPC, but usually the purpose for both of them is to connect VPCs together so they can talk with each other, right? So instead of connecting to the internet, excuse me, and then to this VPC, for example, this VPC can connect to this VPC through the internet, but that will be like really kind of, I'm not sure, let's say more cost and more complex architectures compared to when you simply connect the two VPCs together, right? So both VPC peering and then transit gateway act the same thing, but there is some benefit of a transit gateway over VPC peering. Let's just understand that, right? So I'm adding another VPC, right? And then what happens is like this VPC wanted to connect to this VPC. Usually the first VPC who wants to make the connection is a requester VPC. And then the other VPC which has to accept that request is an acceptor VPC, right? So now these two VPCs are being connected, right? So if I say, can VPC H talk to VPC I? No, they cannot do that because it's only these two that are connected, right? And then if I have another VPC, say another region, and now this VPC in this region is being connected to this VPC in this other region through the VPC peering. Can I say that this VPC can talk to this VPC? No, they cannot talk. If it was a transit gateway like this one, so all the VPCs, for example, this transit gateway connecting all these VPCs together, they can talk to each other because this VPC, this transit gateway and this transit gateway are connected, and these two VPCs are connected to this transit gateway, and all these VPCs are connected to this transit gateway. Now all these VPCs can talk to each other. But in terms of the, I would say the VPC peering, it has to be direct one-to-one connection, then they can talk to, otherwise there is no transitive routing. That's why a VPC, that's why we have a transit gateway that allow for transitive routing. But if it's a VPC peering, there is no transitive routing. For example, this VPC tried to connect to this one, cannot do this. VPC wanted to connect to this one, no, it cannot do that because there is a VPC peering, not a transit gateway. So I think so we did cover quite a part in this one. We talk about the direct connect, the VPN, the direct connect gateway, the transit gateway peering, the VPC peering, and also we talk about the transit gateway route table. Okay, so I am coming toward the last part. I really hope I'm covering that within my timeline. I hope it's not really late, but anyways, I will try my best to make it as fast as I can because I really have to rush home too.